Good afternoon. This is Meteorologist James Longwith here with Dynamic Weather Agency LLC, here giving you a weather update about the severe weather event that's going to unfold today across parts of the central and southern plains. Now, getting into today's video, I do want to first get into basically talking about what we were seeing yesterday. So in yesterday's video, when I was talking about our winter storm system and the severe weather, we only had a marginal risk, or a level 1, for severe weather stretching across parts of southeastern Kansas into central and eastern Oklahoma and parts of the Oklahoma, Texas, border region into parts of northern Texas. Now today, the Storm Prediction Center has upgraded that risk, and we talked about in yesterday's video how some of this risk could expand further on north and into parts of Missouri in yesterday's video, and we can see that expansion in the day 1 convective outlook by the Storm Prediction Center, now with 2 areas under that level 2 slight risk for severe weather today. Now, taking a closer look at some of those places that are going to be affected by this slight risk, that level 2 threat for severe weather today, just north of Topeka, Kansas, near St. Joseph, Maryville, but is going to be under that risk for severe weather today. That's going to be where that low pressure center is going to set up later on today. That center of that low is just going to be off to the north and to the west of that slight risk area. And this is going to be where that cold front, that warm front, and that triple point begins to set on up, where there's going to be an enhanced risk for severe weather within that area. You can see places like Wichita, Joplin, Missouri, and even Kansas City are all located within that marginal risk for severe weather today. And then again, as we move further on to the south, like we said, there's going to be that second area of severe weather today. And it's going to include the OKC Metro, Moore, El Reno, Wichita Falls, Ada, Mineral Wells, Dallas, the Dallas-Fort Worth area, Sulphur Springs, Paris, all the way up towards the Tulsa region in Oklahoma, with places like Waco, Tyler, Texas, Shreveport, Texarkana, Fayetteville, it will located within that marginal risk. And what's going to be driving this slight risk, especially the southern storm mode, is going to be that threat for tornadoes. There's going to be a 5% chance for tornadoes, and so an enhanced contour for tornadoes within that Wichita's, Dallas-Fort Worth area, and just near that OKC Metro, along with the possibility for hail across this area. As you can see, there's that darker color located within the Oklahoma and northern Texas area. That's indicating there's a greater probability within any given point for some hail greater than or equal to 1 inch. Again, secondary hail threat and wind threat too, with that second with that northern portion of that slight risk in parts of Kansas and Missouri and southeastern Nebraska. As we take a look at our wind threat, again, winds are going to be primarily the threat. And I think for the most part, though, there is that tornado threat within there. I still have kind of low confidence on that tornado threat, along with some of that hail threat, just for the most part. I do think damaging winds will be the primary threat for the most part, but that hail threat and that wind threat is going to be kind of more on the back end with this severe weather setup. Now, what we have going on is we have this low pressure system that is moving east of the Rocky Mountains region. We had some upper level support create this surface low across the region. We do have a warm front draped across Kansas into Missouri, lifting northward, and this cold front moving in to western Oklahoma and Texas. That's going to be providing some of the synoptic forcing for the thunderstorms later on this evening and into the overnight hours. That's going to help those storms sustain due to that synoptic forcing. A little bit of a meso low near the Texas and Oklahoma panhandle region. Taking a look at our satellite imagery, you can see some of that low pressure with the spinning in the atmosphere in Oklahoma and again up in the Kansas region where those two lows are. And I just want you guys to note, take a look at the cloud cover going on across this region. And this is going to limit a little bit of that surface instability across the region, not allowing for a lot of mixing and steepening of those low level lapse rates across the region. So this is going to be a slight inhibiting factor for severe weather today due to some of the cloud cover across the region being expansive across the region. Now, taking a look at our synoptic pattern, now we do have a very meridional pattern as we take a look at our PFJ moving in across the Pacific Northwest, this deep upper level trough across the Rockies, and then some of this energy ejecting out with some upper level divergence across the central plains. And I just want to show you there's a couple of fingers of the Arctic jet creating a couple areas of shared energy with our PFJ, and then we have a couple of jet fingers across the southeast and a small finger of our subtropical jet, as you can see, across parts of southern Texas. But for the most part, the PFJ has got this deep upper level trough, a lot of cold air spilling in behind that trough axis, warm air with the slight ridging ahead of that trough axis, bringing that moisture along with it and some upper level divergence. That's going to be good for thunderstorms. And here we are looking at 500 millibars. Again, you can see that trough axis, that cold air moving on into that trough axis, and there's a short wave ejecting out of the base of that trough that's enhancing upward vertical motion, divergence aloft, along with PVA. So that's positive vorticity of action, which is promoting cyclonic spin within the atmosphere. Now taking a look at 850 millibars here, you can see a low-level jet moving on across the region, 30 to 40 some knots, and that's going to basically help increase the transport of warm air advection along with low-level moisture. And this low-level jet also is increasing helicity across the area for tornado genesis. And I just want to show you how that low-level jet is going to progress as we move into the evening. Here we are at 18Z. This is just a little bit later than that 12Z analysis. You can see that low-level jet is going to be increasing as we go throughout the day. And you see that high pressure off the eastern coast of the United States and how those winds are wrapping anticyclonically around that high pressure. And that's what's been helping bring this moisture and this instability back into the area ahead of that surface low, before that surface low developed across the region. And then you can see that parent low up in the Canadian prairie, where we're having some of that winter weather up there, where that cold air is moving on behind that, and we're expecting snow in parts of the northern plains and the northern Mississippi Valley region. And you can see more about that in our video that we posted yesterday. Now, like I said, with this low pressure system, that high pressure cell, we're seeing a lot of moisture being drawn in from the southern plains into the central plains, just ahead of that surface low. As you can see, as we look through this loop, you can see that moisture screaming from south to north, bringing those dew points into the 60s across the region ahead of that cold front. As you can see here, by 21Z, this is about 4 p.m. Eastern Standard Time, 3 p.m. Central Standard Time. Dew points reaching the 60s across the region. Those southerly winds and that low-level jet bringing some of that moisture and some of that warm air ahead of that surface cold front. And you can see here on this graphic that northern extent of that moisture reaching all the way up into Kansas and Missouri, near that triple point of that surface low, just ahead of that region where we're going to see that second area of severe weather, where we're going to have that moisture pocket up within that region. With that moisture screaming northward, also the instability is going to be building on in with it. This is taking a look at our surface-based instability. This is CAPE right here. This is what we call convective available potential energy. Is the measure of the amount of kinetic energy stored within the atmosphere. And this is the energy that thunderstorms that develop in this environment have to feed off of. The more energy there is, the stronger the storms can be, and then also the stronger the updrafts in these storms. Again, you can see that instability across the region in parts of Oklahoma. The new models indicating maybe some stronger instability over the area. I do think this is slightly being over forecast due to some of that cloud cover on over the region, but for the most part, 1,500 to about 2,000 joules per kilogram of instability. So sufficient instability for severe convective storms to develop in this environment to feed off of. And again, taking a look at that, you can see that northern extent of that instability with that moisture axis reaching up into parts of northern Kansas and Missouri, where we have that second area, that northern portion, that level 2 threat and that slight risk for severe storms. Now, taking a look at our energy helicity index. This right here is going to show where some of that best surface-based instability is, along with that surface to 1 kilometer shear. And this is going to be probably where the best tornado potential is going to be. And this doesn't extend that far northward, where that second slight risk area is, where mostly the potential for damaging winds and hail will be up into that northeastern portions of Kansas, northwestern portions of Missouri, and that extreme southeastern portion of Nebraska. Now, for the most part, I think the tornado potential is going to be confined to south of I-40, across parts of south central and southeastern Oklahoma, and into parts of northern Texas. And this is co-locating really well. This EHI right here, indicating where that best surface instability and surface 0 to 1 kilometer shear is for our significant tornado parameter. As again, you can see here as we go throughout the day, that significant tornado parameter is basically co-locating those exact same locations where those greatest EHI values are. And again, taking a look at some of our storm relative helicity, as we move into some of those yellows, orange values right here, we're seeing about 200, 250 meters squared per second squared for the most part across parts of central, south central Oklahoma, into parts of northern Texas ahead of the cold front. Where that low level jet is going to be moving across the region, increasing some of those helicity values that we see right here. And that's going to enhance some of that tornado potential as we have some of the more back surface winds within this area just ahead of the cold front. And again, these values being 200, 250 meters squared per second squared, basically is what they're telling us. There is the potential for cyclonic rotating updrafts, and that means that there's going to be supercell thunderstorms, at least embedded within this line system, as we take a look at our high resolution forecast model here in just a little bit. That FutureCast Radar, as you'll see, these storms are going to be quite linear in nature, so we could see some embedded supercells within those thunderstorms with rotating updrafts, and with those values just being under about 300 meters squared per second squared. Now, there's a slight pocket in there in northern Texas. But for the most part, these are basically just saying tornadoes are possible, but we're not expecting any significant tornadoes to develop out of this. So anything EF2 plus for the most part. So going to be on the lower end for tornadoes. Now, taking a look at our surface-based CAPE and our crossover winds, those red wind barbs are indicating our surface winds. As you can see, they're coming from the south, southeast. Those blue barbs are 850 millibar winds. Now they start veering a little bit more westerly, becoming more southwesterly, and then our 850 millibar winds are more from the west-southwest. So you can see those veering of the winds. That's indicating low-level directional wind shear, and that's good for tornado genesis, along with that instability axis within that region. Now, to take a look at one of our forecast soundings here, I do want to point out again some things. We have that curvature of a hydrograph. That's again due to that low level directional shear. We also have that elongation of a hydrograph. That's due to the speed shear in our atmosphere. Taking a look at our surface to 1 kilometer wind shear, it's at about 23 knots, so that's a little weak, but as we get to our surface to 3 kilometers, near that 35 knots that I like to see. Surface to 6 kilometer, well above that 35 knots, and increasing due to that basically, you know, that 50 knot jet at 500 millibars, surface-based CAPE around 1300 joules per kilogram. Like I said, I think that 2000 is slightly over forecast. I think more towards 1500 joules per kilogram is what we're going to see for our surface-based CAPE for the most part across the region. Our lifted indices are moderate, -6, -7. Our most unstable, -7, are forecasted as -9, but for the most part, it's going to be a moderately unstable atmosphere. There is a slight elevated mix layer here that's helping steepen these mid-level lapse rates right here, which is creating a fatter CAPE in the mid-levels. That's going to increase the updrafts vertical velocities within this area. That's going to help support some of that hail growth within this region, along with that steepening lapse rates. That's allowing for some cooler air into the region. That's also going to promote some of that hail growth within this area. And this elevated mix layer also helps with reducing the melting of those hailstones as they fall to the surface. And with that increased vertical velocities of the updraft due to those steepening lapse rates within this region is also going to allow for those hailstones to be lofted and suspended in the atmosphere longer, help support some bigger hailstones, allowing for more moisture and water droplets to collide with those hailstones, allowing them to continue to grow in size. As you see some of the analog soundings here, we have anything from 1.25 inches of hail to about 3.65 inches of hail. And I'll just show you here the maximum hail swath based off the HRRR what it is expecting here. Again, the storm relative helicity value is 256 meters squared per second squared, so around 250 meters squared per second squared. So supercell thunderstorms with rotating updrafts will be possible based off of that. And we're seeing those increased relative helicity values due to, again, that low-level jet moving on through the area and those back surface winds. Critical angle 81, that's a really good critical angle to have. And again, You can see right here, the possible hazard on this sounding is indicating tornadoes. So tornadoes are possible with this. Low level directional wind shear, we have instability, and we have a elevated mixed layer dry air moving on into that. That's going to help shrink that updraft, promoting those stronger updrafts, which is going to allow for that stretching of that updraft, lowering that pressure, allowing for that surface vorticity to develop along the surface, allowing for that tornado to potentially reach the ground. Now here's the HRRR model, again showing us where some of that maximum forecast estimated hail size could be. And this is showing us where some of those more stronger updrafts with these storms based off the model is expected to be. Take a look right here, this storm track across parts of northern Texas. And these blue values are indicating where hail is about basically above 1/4 of an inch, near about 3/10 of an inch, to about when we get into those teals and even some of those greenish colors, about 3/4 of an inch to an inch. So as we move into this track across northern Texas, 1/2 inch to an inch of hail, maybe greater than an inch of hail possible with this storm track down here. Hail again across parts of central Oklahoma and across that parts of northern northeastern portions of Kansas into Missouri, where we have that secondary threat for hail near that triple point of that low pressure system, where we have a lot of cold air moving on into that region. And this is just the forecast model solution. So again, this is just a model solution. This is not a forecast, and this is just showing you where the potential could be for greatest portions of hail. So central Oklahoma near the OKC area, across parts of northern Texas, and again across Kansas, northeastern Kansas and northwestern Missouri, greatest potential for hail based off of the model and the environment that these storms could be developing in. Now, before we take a look at our FutureCast Radar, I do encourage you guys to head on down to that like button and subscribe to our channel. It does help out that YouTube algorithm, allowing more people to see my videos. And be sure to share this video with them. Help them be weather aware. Does my part as a Weather Ready Nation ambassador with the National Weather Service in promoting a weather ready nation. Also, it makes it more enjoyable when more people are able to watch these videos and are posting their comments down there, and I'm able to help them by answering those comments. Last but not least, head on down to that description section. There is a link to our social media pages down there and our website, dynamicweatheragency.com. If you go to our website, you can see some of the weather consulting and forecasting services I offer here at Dynamic Weather Agency for a plethora of clients within the agriculture, snow removal. I do stuff for school districts, along with Department of Transportation, and I even do stuff within forensics, along with doing case reports for insurance companies and doing hail swath maps for roofing companies. Along with, I do storm chasing and media services. I've done that. You can find us on the Weather Channel's TV series World's Wildest Weather. I've been on the Good Morning America, ABC, NBC with some of my storm chasing footage from some of the tornadoes that we've captured before. So we do that, and be sure to check out some of those videos here on YouTube. I got quite a few chasing videos. Have not been able to do that lately because of me being stationed here doing stuff with the DoD and my responsibilities doing that. I haven't had much time to be able to chase. So the chasing videos have been on the down low, but for the most part, I'm still able to create weather content right here. And if you guys love what we're doing, there's a link down there for our Patreon page where you can help support this channel so I can continue to make free content for you guys like these weather forecasting videos. So be sure to do that. Now let's take a look at our FutureCast Radar. So taking a look at our FutureCast Radar, this is one of our high resolution models that we have going on right here. And for the most part, this model is verifying really well with what we're seeing right now on radar. We do have a complex of thunderstorms in parts of northeastern Kansas where the National Weather Service is issuing a couple of special weather statements, so some sub-severe warnings on some of these storms in northeastern Kansas. But as we move in through time, by the next hour, by the time we get into about 3 p.m. Central Standard Time, we'll see some thunderstorms begin developing across the I-35 from central Kansas all the way down to central Oklahoma. And those storms are going to quickly intensify by the time we get to 4 p.m. Central Standard Time into a linear segment. Again, for the most part, hail and damaging winds, I believe, are going to be the primary threats as we go through the evening into the overnight, but there is still that low potential for tornadoes today. As these storms begin to back build, by the time we get into 6 p.m., we'll start to see some more isolated convection begin to develop across parts of south of the I-40 corridor, and this is where the tornado potential is going to be the maximum as we have these more individual supercell thunderstorms that are able to develop within this environment where some of that best surface instability is. gets the best SRH value, along with the best 0 to 1 kilometer EHI, that energy helicity index, indicating again where that best surface-based CAPE and surface to 1 kilometer wind shear is going to be. Again, more linear segments up to the north, some isolated hail with some embedded supercells up in the portions of Kansas into Missouri, but for the most part, you can see this line segment right here. Tornadoes are less likely on these linear segments. It's hard to get those mesovortices to develop in this type of environment with the more zonal winds, even though we do have a little bit of low-level wind shear. For the most part, damaging winds are going to be the primary threat up here. Again, as we move into about 8 p.m., again, some isolated supercell thunderstorms developing south of the I-40, near I-35, especially near Wichita Falls. Take a look at this large supercell thunderstorm, and this is going to be probably the best storm of the day for tornadoes and probably damaging winds today. This storm is going to go from Wichita Falls towards Sherman. There's also another isolated supercell beginning to develop on the tail end of this cold front with this line segment, where there's also another potential for maybe some tornadoes south of the OKC, north of Lawton, and that's going to be moving off to the east. And then our hail potential with maybe an isolated tornado threat with some of these storms ahead of that along this convergent boundary just ahead of that storm system. Here we are at 8 p.m. Central Standard Time. Again, look at that supercell from Wichita Falls towards Sherman. Here we are at 9 p.m. Central Standard Time. And by the time we move into about 11, I think the tornado, 11 p.m. Eastern Standard Time, so 10 p.m. Central Standard Time, I think the tornado threat is going to begin to diminish as we start losing some of that surface-based instability. Now, the winds of that low-level jet will continue to increase due to that nocturnal low-level jet moving on in, but for the most part, these storms are going to really start congealing into those linear segments, and for the most part, by the time we get into this hour, I think we're going to start seeing that tornado threat decrease, maybe still have an isolated hail threat, but mostly damaging winds after this time. So I think the best threat for tornadoes today is going to be between that 5 p.m. Central Standard Time and 10 p.m. Central Standard Time. Now here we are at about midnight. Again, that line segment is going to continue to rush off to the east, and that's going to start to accelerate as we move through the nighttime hours as that cold front continues to advance. Here we are at 4 p.m. Central Standard Time. Ongoing line of convection all the way from Arkansas down into parts of Texas with showers stretching all the way up into basically the northern Mississippi Valley, up into the northern plains, where we're going to start seeing some snow form on the backside of this parent low pressure system that is all the way up in the Canadian prairie, that's going to begin drifting eastward with a lot of cold air wrapping around the backside of that low.